One more minute.
Sorry?
One more.
Okay.
It's still connecting.
Yeah. It's recording now.
Recording?
We're live and it's recording.
Yes.
So, Mr. Ganesh, we are ready.
All right, great. All right, a very good morning, a very good afternoon, good evening to the speakers and the audiences, wherever you are in this globe, watching live on YouTube. A very early good morning to the students from University of California. It's 1 a.m. over there. Thank you for making it at wee hour. I'm Kaneshwaran Govindasamy. A big welcome to everyone. The COVID-19 crisis has blindsided governments and companies. Stay-at-home guidance and social distancing measures across the country and globe have dramatically changed the way we interact, learn, and conduct business. Facebook says there is enormous high intensity of traffic, 10 times of group video calls. There were plans by FB in Europe to convert from HD to SD to lower the intensity. User experiences are changing. It's about of quality of service and quality of experience. Video meetings were all-time high. Even mobile operators doubled up the efforts on self-care apps for their customers by introducing value-added digitalization, increase of digital assistants, automated chatbots, handling new type of complaints. In the move of this new architecture, things like automation, reporting to the edge, auto scanning certainly became less human touch, more automation, ensuring we are moving from a legacy 2G, 3G, 4G hardware to a very software-based solution. Subscribers have different type of requirements. Customers' behaviors are changing. Customers' information are so critical. There's a huge churn of data consumption. To address this, mobile network operators are looking at A, capturing the data, B, analyzing the data, also C, employing real-time changes in the network. The best practices in the industry is a technology that allows capturing the data, analyzing the data, and deploying new services, features, rules, requirements, routing based from the data. Also distributed edge enabling high dense of IoT that becomes a crucial piece with flexible cloud. So COVID-19 is the first pandemic in human history where technology and social media are being used on massive scale. That's where 5G has been designed to meet the very large growth in data and connectivity of today's modern society. 5G Edge brings processing capabilities closer to the end user or the source of the data. The other key features of 5G is about immersive experience, 360 degrees experience, best-in-class dense environment stadiums and festivals, features, rules, requirements, routing based from the data, and then rural broad mining, public safety, and with the need of massive amount of data throughput depending on specific use case requirement. So customers want to have control of the network so that they can monitor the network while they are on the move, whether on a moving car, train, or plane with a seamless connectivity. That's where 5G guarantees a high throughput download speed, more than 1 gigabits per second, guaranteed low latency, less than 1 millisecond, and high bandwidth availability. So today we are going to hear more from the speakers. So, then rural broad mining, public safety,
There is an echo. Fix it.
Before I introduce our guest speaker, allow me to say a few words here. What will future mobility look like? What will it cost and what will it take to get there? As demand patterns shift and environment stresses increase, what transportation will we need to get around and deliver goods and services? How can collaboration, innovation, and investment speed up the transition to a smarter, better integrated, and more sustainable future? The Global Mobility Virtual Conference brings together leaders with a shared commitment to establish sustainable and seamless mobility. Let me introduce Puan Hanis Lam from Kuala Lumpur, Malaysia, to discuss further on Global Future Mobility Virtual Conference 2020.
Thank you so much, Mr. Kanesh, for inviting me to be part of the panel today. So I'm Hannes. I'm from Best Events Productions, and basically, I've been passionate about commercial drones, about smart mobility, and actually a recent study shows that the manufacturing, public transport, retail, and agriculture industries all highlighted the importance of receiving input from a large network of low-cost sensors, as well as the ability to control remote equipment with no delay. So furthermore, across all sectors, the respondents indicated that 5G technology will actually improve issues that center around data security, connectivity, and human process automation. So with looking at this, we've been talking about 5G a lot, and we're expecting the peak bandwidth and user experience of bandwidth of 5G networks to be 10 times higher. And with 5G, it comes with its own benefits, but it also imposes some challenges on the existing telecom transport network. And existing technical infrastructure, including the equipment and the network architectures, does not fulfill the requirements of deploying 5G network. So while addressing these challenges, it is also important that an optimal cost solution is considered for successful deployment and rollout of commercial 5G services to meet consumer demands, and at the same time securing market leadership with sustainable growth. So as mentioned earlier, because we've been in the market producing our own events related to tech and innovations. Last year, we actually had our first global drone conference, and we had another one this year just before the COVID-19 pandemic lockdown. So we were lucky in that sense to have managed to run that event before, we don't know when the next physical event is going to be. So we understand that for 5G to work on public transport, it can help with high-speed internet access on public transport, which I think all consumers they find it a norm to have internet wherever they are, and then to have connected traffic cloud to aggregate and analyze real-time data from connected vehicles, infrastructure, and devices to assist operational decision-making. Also, it will help in real-time high-resolution vehicle video surveillance and AR wayfinding applications. So that's in terms of public transport and 5G. For drones, which I'm also excited to learn from the other experts here, because drones and 5G, there's so many things that you can do. You can establish UTM, unmanned traffic management systems. You can improve scaling flights beyond the visual line of sight. Of course, there's also data transmission, and which brings me to the virtual conference that my company is going to be organizing end of this month, which is called the Global Future Mobility Virtual Conference on the 29th and 30th of June. So Mr. Kanesh here will be also joining us, and in his session he'll be addressing how can cities manage and verify who and what is connected and shared while protecting information and users, and also the challenges that I mentioned earlier about internet adoption and usage gaps along geographic and economic lines. So at the Global Future Mobility Virtual Conference, we have many exciting speakers that hail from Europe, from the US, and of course Asia, Indonesia, Hong Kong, and local partners in Kuala Lumpur, Malaysia. Some of the other speakers include like Oliver from Lilium, so he's going to talk about Kpis, and then we also have sustainable aviation, where Dr. Anita Sengupta will be speaking. She is a rocket scientist, our first ever rocket scientist to join a panel. We've also got Professor Roberto from RMIT from Australia, and we'll be speaking about air traffic and urban transport in developing countries with Shravani Sharma. So many exciting topics to cover, so many established speakers that will be here, and I'm going to actually play a video to show you a teaser of what this conference is about. So are you ready?
Yes.
Okay, here goes. So that's my part. Thank you again, Mr. Kanesh.
Yeah, excellent. Thank you. Thank you, Hanis. Thank you so much for being here. I'm really appreciated for that. So before I introduce the next participant, allow me to say a few words here. With available home subscriber server, HSS, and home location register, HLR functionality, CSPs around the world can find the best solution to HLR, HSS deployment, and not seeing through software, not through hardware. So with the software-centric approach, one HSS server and its software features can perform the tasks of many specialized servers. Let me introduce Miguel Monforte Nicolas from Lyon, France, to discuss further on non-standalone to standalone, the evolution of HSS into 5G and challenges.
Good morning. Thanks, Kanesh. Let me share my screen. And then I can do the... So obviously, first of all, I want to introduce myself. I'm a telecom engineer. I did an MBA in IE Business School almost 15 years ago. And during that time, I have co-founded 2 companies around the mobile space. So let's say that I've been here when SMS was trendy and WAP was amazing. And 5 years ago, we started building HLR-HSS. So let's say a small change from what we used to do before. And that role, I'm the CTO of Suma Networks. Well, if you're interested, that's the link. And why I'm saying this, obviously, because let's say that I have certain bias towards 5G. I've been for the past 5 years working on the subscriber data management. So although I know the rest of the network, I know radio, I know session management, let's say that my day-to-day work is on the subscriber data management. No? And it's true that it started not too long ago when we talked about 5G, and at the beginning was some sort of whisper in the sound, like, yeah, there's going to be some 5G, you know. And I remember when it was first launched 4G, took years really to develop. No? We had first dongles, and then we had some computers with 4G, and then maybe we had some phones that had 4G. No, in the case of 5G, it seems that everything is going super fast. No. So if we compare to the previous changes on the industry in terms of 2G, 3G, 4G, and now 5G, for me, instead of being an evolution, it seems to be a revolution. We are completely bumping all the protocols and we are doing it from scratch again. And that is going to impose certain challenges. Okay? It's going to be something new for a lot of us. Okay. So my interest here is obviously to know what's going to be the landscape, how it's going to change the vendors, the industry, the players, everything. No? So if we do a quick summary of what we've seen so far in terms of the core protocols, we have the 2G, there was MAP, there was the old good days where we had the SS7 ruling the network. The HLR was something really clunky, really specialized. It had lots of complex flows to do call, to do SMS, to do registration. We kept the same technology in 3G. We added the PS core, but we didn't modify anything in terms of how it worked. Okay, we simply overcomplified something that was already complex. And I think it was a good decision to start working on 4G in a new protocol in diameter. That allowed us to remove the old SS7. It was too complicated, especially for the interoperability. Each vendor at the end decided what to do, and obviously the standards are not to follow them. That's the good thing about the standards is you have a document that everyone can understand however they liked. So 4G represented the first, let's say, big evolution. 2G, 3G were simply along the road of what we had. 4G was the first in which we removed dialogues, we removed request response that were framed, that were complicated. It was simply, it's get me the information, get it sent back to me. And in view of, well, we are going to use IMS, and then IMS doesn't have this centralized view of the HLR. Obviously, we need to have someone to take care of the SMS, the voice calls, the call forwarding. And then we started to add functionality on the IMS. We had to add the Momentum server. We had to add the IPSM gateway. Things that at the beginning were not designed, no? But they were built on diameter, more or less. We get it to run. Okay, it's still some bumps along the road, but let's say that it works. But then now in 5G, we have thrown away everything again, and we're going to use HTTP2. And that means that we're going to see now, this represents a new big change. And more than a change is, well, one of the things is we relied on 4G to go back to 3G and 2G to do the fallback. Now when we move into 5G, there is no way we can do fallback to 3G. So voice calls have to go through IMS, okay? And the issue with the IMS is you have to deploy the whole suite of elements. You have to deploy the IPSM gateway, the IMS, the MMNTEL, the MSRF, everything in order to provide the same services, because obviously I'm not talking about IoT or M2M, I'm talking about consumer services. So with an operator that has legacy 2G, 3G, now they span it into 4G, now they want to talk about 5G, they need to make sure that they provide everything in 4G first, and then they can start talking about going into 5G. Because if you go to 5G, then there is no way to fall back to 3G to make phone calls anymore, okay? Which means that we have to get the roaming on IMS finally sorted out, okay? Whether we go all to the local breakout or we do another thing, but we have to get all the operators to agree and to finally implement roaming on IMS, okay? And IMS is not the easiest protocol in terms of getting it to run and connected, okay? It's if we've seen operators reluctant to deploy IMS and roaming on IMS is because it's not that easy. And once you start working on it, you realize that well, it's more complicated than when we expected. And operators have simply been pushing it. Yeah, we will do it next year. Now they have to do it. And one of the key elements is, if you can see the last item is sunsetting of all technologies. There's more and more operators now trying to get rid of all the 2G, 3G spectrum and then harvest those for the 4G, but then see if, well, I can remove all that from my network, okay? But the issue is you will have certain users that want to go roam on certain countries where you need to have an HLR. And I was discussing the other day, specifically for a customer to say, well, my network is 4G, but I need my customers to go roaming on another country to have an HLR. So we need to have a sort of an interworking function for an HLR, okay? And on top of that, meaning that it's not that complicated then we add the HTTP and the cloud native, okay? So it's something that operators are not accustomed to it, okay? It's, they were doing good with bare metal, now we put them into virtual machines, now we're going to put them into cloud native, okay? That's too many changes, too many evolutions, which adds to the complexity and the uncertainties, okay? So if we put it into a diagram, this is more or less what you get into an HLR-HSS, okay? So you have the connection to the old 2G, 3G network, the BO Wi-Fi, which is some sort of trendy now. You have the EPC, you have the 5G and the IMS, okay? And all these have to be aligned and they have to be correctly orchestrated so that everything works, okay? So when you have a user going into roaming and is using the authentication vectors, those are generated some sequence. Those sequences have to be updated for the different elements. When you do a call forward, that call forward is on the IMS, but then it has to be passed on to the HLR so that you have the same call forward on the HLR, okay? Those sort of flows we have to start understanding, and we barely scratch the surface, okay? So for the moment, 5G, it's pure conceptual. We haven't really get into how you interoperate with all these elements and how we're gonna be able to do this, okay? So just to give you a brief overview of what things we used to do on the HLR, we have something like calls, SMS, USSD, call forwards, all those are managed by the HLR. So it is really, really complex system that had a really complicated communication protocol, which is the SS7, which has 4 layers. And we had the dialogues in which, okay, the SRI has to trigger a PSI, the PSI triggers a PRN, the PRN then answers the SRI. So there were really, really complicated things. And that ends up in lots of information that you have to store on the HLR. So you can see on the bottom that we have 100 entities on a database. It means that you have the access restriction data, the operated MA bar and camels, PDPs, supplementary services, teleservices, all that required just to make a few phone calls and do an SMS, okay? And the complicated part is it's really complicated to put it into a microservice definition, okay? Because the interaction between the different dialogues and the different kind of messages makes them almost impossible to split into something simple, okay? So you have something that is all that is clunky, but you need to keep it for an undefined period of time to be able to get those users to roam on low coverage area where you still don't have 4G in your country, or when you go to roaming, okay, you will go to a different country and then there is no 4G, 5G, you need to still use the 3G, okay? So you need to keep this maybe for the next 4 or 5 years, okay? And then in terms of how we jump into the UDM, well, I would say that the UDM is more of an HSS than an HLR. Fortunately, we simplified the information that we keep and the flows that we have to do on the UDM. We will have information about access, roaming, SMS, APNs, which now have a different name. But we remove all the logic from the HLR. So that means that some of the complexities that we had on the HLR, we have simplified. But that means that also that logic has to be moved into the MMNTEL, the IMS. So it's not free, meaning at a point in time, you have to decide who is going to do that, okay? And on the, if you see the diagrams for 5G that look amazing, really, because there is no voice and SMS, okay? Then when you start adding the voice and SMS, that gets, again, ugly, and you have lots of protocols that you didn't have in mind when you wanted to do, okay? But at least it's a simplification of something that was really complicated, okay? And because it's based on HTTP JSON request response, it's really much more efficient. You can do more things with a simple definition on an API, open API.
Sorry, Miguel, you have another 1 minute to go.
Okay, so yeah, I'm going to finish. So HTTP was the communication protocol of choice. I'm not too in favor of it, but at least it's going to help us on the cloud native service discovery functionality. Okay. So one of the main topics that we are going to be fighting on the SDM, it's obviously this is going to be a cloud native, so we need to work on that. We need to work on the microservices, how we can split those big elements into something more simple. We need to get rid of all the telecom protocols and work on the IT domain. The HTTP2, which is going to be the holy grail, well, we need to start working on that and see how it really performs. The service discovery, I still find it that is too vague in the definition, and there's going to be things that we need to start interoperability testing. And the only good thing is the Open API has a good definition on the protocol exchange information. Okay, so that's easier than we were doing before on SS7. So, well, the change is here, and obviously we're going to have tons of fun and tons of things to do. Done.
Excellent.
Let me stop sharing.
Yes.
Very good. Thanks, everyone. That was a quick overview of what we're going to be seeing on the few next years on the subscriber data management.
Thank you. Thank you, Miguel.
Thanks to you.
So, all right. 5G will achieve blistering speeds, or in other words, much higher bandwidth compared to previous generations. Higher capacity all the way from the access interface towards RAN elements to the mobile core to allow for the higher capacity of 5G traffic. These higher bandwidth requirements mean that the underlying IP and optical transports that are used to transport the mobile traffic will also need to be upgraded and re-architected. Networks will also seek to achieve much lower latency, much higher availability, and much higher scalability that demand by previous generation of mobile technology. So let me introduce Mohamed Radwan from Sydney, Australia, to discuss on IP transport network supporting 5G network.
Yeah. So hi everyone, and thanks Dr. Kanish to have me to this exciting one. Can you see my screen?
Yes.
Hello?
Yes.
Great.
Yes.
Yeah.
All good.
Yeah. So as I will be talking about IP transport, which mainly will be 5G is the customer for IP transport along with other services like internet. But before we start, let me introduce myself. So my name is Mohamed Radwan. I'm a principal solution architect with almost 20 plus years of experience in telecommunication service provider, data center, cloud. And I built and designed many of the Fortune 500 company design in Europe, Middle East, and Asia Pac. So let's start talking about what transport network promise to achieve for the 5G requirements. But before that, let's do a quick recap about what are the main requirements coming from ITUR. I will just highlight the main requirement related to the network, which will affect our design, and we need to change the way we do transport and networking, as Mr. Kanwash mentioned. So here, one of the main point is the peak data rate. So as you can see here, there will be a big growth from 1 gig per A node B, or for 5G it will be new radio G node B, from 1 gig to 20 gig. This is a huge increase in number of bandwidth and speed expected in the access. The per user experience, or the sustainable data rate for each mobile user or each handset, would jump from 10 megabit per second to 100 megabit per second, a 10-fold increase as well. Another very critical point for us working on the transport network is number of devices per kilometer. So in 4G, it was around 100,000 of devices, but with 5G, with a lot of IoT devices, AR, VR, this number is expected to be in the ranges of millions of devices per square kilometer. Another one is area traffic capacity. So as we mentioned, somehow related to number of devices, this number of devices in a single kilometer may actually produce traffic up to 700 gig per second. So this is actually a huge number of packets. That's why we see a lot of trends and a lot of adoption for the 400 gig interfaces to support this requirement. Last but not least, for the criteria and pillars related to the transport network is latency. As we all know that this latency is mainly in the radio. So we are trying to achieve 1 millisecond latency from the end user or the headset to the radio. But to achieve this, maybe we need to change the way we used to work. So some of the terminologies or concepts from SDN like Kpis and decoupling need to be deployed, and we need to bring some data intelligence, some compute into very close to the users. So by doing this, maybe we need to introduce some network and compute at the edge, which we call it edge computing. So after mentioning the requirements, let me try to talk about what we need to achieve from a transport network. So we need to support a higher capacity. As we mentioned, instead of the old days 2G, 3G, we used to have this base station connected to the transport network and aggregated directly like a mobile hole, like a mobile backhaul, sorry. So now this will be divided into 3 holes: front hole, mid hole, and back hole. And you need to support a very high bandwidth over there. We need to support network slicing, and I will give you a use case about network slicing and how to make sure that the transport network is service aware, understand the difference between the requirement for a service like enhanced mobile broadband, which mainly high-speed internet, compared to another service which is ultra reliable, low latency communication for maybe robotic surgery or maybe for smart traffic. Another very important piece of the puzzle which we are currently working in is how to, as Dr. Magwell mentioned, how to adopt the cloud native, how to build the data center or the mobile core to support cloud native containers, support how to make it like microservices, implement it like small Docker, how to make the big application, the monolithic application, how to divide it and make it like small microservices. And also there is a trend for operator, shall they build their own data center and build their own telco cloud, or they can do a hybrid model and put some workload in the public cloud and then do the hybrid cloud and assure the communication between the workload hosted locally in their telco cloud and the workload hosted in the public cloud. Last but not least is programmability, which will bring adoption, which will bring simplicity. And for example, for 5G developers, they will work with the network or the transport network like a programmable interface with API. They can be able to steer the traffic based on their requirement. So just two sample cases. So this is one of the trends in the new way to design the network. So instead of having one big domain for the network, it has been for quite some time how to divide your network into multiple domains, and each domain will be responsible by a team. Like you have a dedicated network for the RAN access, another one for a transport, to connect all these RAN to the mobile core and the edge and data center. And we have a lot of new protocol and like segment routing, how to carry to assure there is labeled switched path end to end using some enhancement to BGP protocol like BGP LU, how to share the visibility about each network with a controller, and this controller will be able to steer the traffic based on the requirement. And this controller, like SDN controller, somehow it's called path computation engine. And then just to be aware of the time, I will show you another example of network slicing. So as we said, we have multiple network slice, and each one of them will have its own maybe network slicing index. So we have network slice 1 for enhanced mobile broadband, 2 for ultra reliable low latency communication, 3 for massive machine-to-machine type, or we can call it massive IoT, and finally V2X, vehicle-to-vehicle. So when it comes to transport network, as you can see, here we have multiple devices. Each of them has different capabilities. So maybe the devices in red, and sorry, the devices in gray are very high speed router with a lot of maybe 400 gig connection between them, while the devices in black are actually low speed routers. So most of the connection here is 10 gig and 100 gig, but they are really very low delay on these links. So based on the requirement, and thanks to a new technology, it's been here for quite 5 to 6 years, it's called segment routing. We can represent the network as we call it segment IDs, and we can expose these segment or IDs to the application. So based on the requirement, if I want to use a path which will meet my requirement from high speed bandwidth, I can build my path using maybe this SID, which is 70. If I want the traffic to come from E node B to the core, I will choose 17114, and this means I will only use the devices with high speed links. Okay, so the traffic will be steered using this slice, or we call it flex algo. If I want to have a traffic to go through a path which impose very low delay and very high availability, reliability, I will start using a different SID or a different segment router ID, in this case 17214 from 17213, and the traffic will pass through the different slice on my network. For any reason, if I really don't care if the traffic goes through high speed or low latency, I can keep it simple and use maybe the standard instruction, and the traffic can go whatever path is available. So this is just a sample of network slicing. And just to sum up, I just want to make sure that from transport layer and the promise to support 5G, we are sure that our transport network will be service aware between the different services, as we mentioned, either it's enhanced mobile broadband, high-speed internet, or low latency, or IoT. We will assure low latency end-to-end by maybe bringing the compute and the network intelligence to the edge, support higher bandwidth, as I mentioned, the new trends and the new standard for the 400 gig port, high availability, and service chaining, which are two big topics. Maybe we can talk about them in future sessions. Programmability, as I mentioned, now the network is open. You have a lot of ways to communicate with the network using REST APIs, using netconf, and doing some data modeling with JSON, Yang, and so on. All of this will lead to simplification and enhance the way we transport the network and give the user experience which people are actually looking for. Thank you very much, and I will be here available in case of any question.
Thank you, Mohamed Radwan. Excellent. We will take the question and answer session later on. So let's move on. All right. So since the entire world is under lockdown, it is the time of the year when academic and teaching activities are in full swing in most parts of the world. The current pandemic situation has paved the way for a ground test of virtual classrooms as a prominent tool of learning in the current times. Schools, colleges, universities, corporates, and even world bodies like UNO, WHO, G20 have had to switch the virtual mode of learning and communications. Let me introduce Said B. Aziz from Massachusetts, USA, to discuss on the impact of 5G in education, virtual reality, and virtual classrooms.
Hey everyone, can you guys hear me okay?
Yes.
Hi, and thank you so much, Ganesh, for giving me this opportunity. Both 5G and the impact of 5G in the field of education are my most favorite topics. So I'm honored to just touch a little bit on that subject. A little bit about my experience, you introduced before. I'm Sayed. I live in Massachusetts, United States, and I've been part of the wireless industry since past 10 years now. I started when 3G was at its peak, and LTE was kind of at the stage where 5G is today. I'm not gonna go too much. We have all the experts here. We kind of know by now the differences. I'm not going to go into details about the differences between 3G, 4G, and 5G. But what I would really like to talk about is when I started, I remember that whenever we talked about all the exciting things about LTE, people used to question, like, what can we do with 6 megabits per second? Like, what can you do with that much of bandwidth at that time? And because we didn't have applications like the Facebooks and the Ubers or those kinds of high bandwidth applications for that time. So my take on this, based upon the experience, is that all the amazing things we talk about 5G will soon become a reality, and ultra wideband 5G network is not too far from us. So the question comes: what can we do with all these 5G very high bandwidth, mobile edge compute, low latency, etc. And I think this is the perfect time with the given circumstances with the COVID-19 and you know, all this shutdown of the schools that we are experiencing all around the world. This is the perfect scenario to talk about how we can convert our learning systems into virtual environments. So I would just like to focus a little bit about with our existing technologies, but for a realistic experience, like how we are required to, for like today, we are required to, if we want to convert a virtual environment, today we are required to carry our heavy compute machines with us. Let me share the screen. I don't have too much to share, but so based upon all the scenarios, I would really like to touch a little bit on the XR and how AR, VR, and mixed reality can help creating a realistic learning experience. So like I said, we were still able to do everything on 4G and on the regular Wi-Fi that we have in the schools, but the problem is stability. We were never able to actually design an application and actually do what we wanted to do and just promise that application throughout, to promise the performance of that application throughout. So when 5G got introduced to us, then we and I was part of some really cool projects because of the company I work for, Verizon Wireless. I got the opportunity to actually do some nice things in the field of education where we could see how 5G is enabling the things which we could not even imagine during the time of 3G. So this is kind of like the architecture of like a current XR application or environment that we would use today, and like any XR or especially the virtual reality environment, the latency required would be like a good latency would be 5 to 20 milliseconds. This is when, if you turn your head on either direction and if the environment doesn't change with you, like this is kind of what actually 5 to 10 millisecond means in virtual reality. If you turn your head and things don't respond as per you expect, then the brain kind of start losing focus, and that's when people complain about being nauseous and all those things. And also it does not give us the more realistic experience. So basically, how can we, in my opinion, how can we achieve like the visual quality, sound quality, and the interactive scenario which actually provides a more realistic kind of experience. In my opinion, 4G network is the architecture of the 4G network is quite cumbersome. All the traffic today goes through the service gateway, and then that kind of divides or sends the packets accordingly where they're required to go. Whereas today, with the virtual nature of the 5G network, and now we can divide the user plane and the control plane, and then that's what enables us to actually do network slicing, like some of the other folks mentioned today. And because of that, imagine a dedicated 5G network for a school or institution, and how much they can take advantage of actually having a reliable network throughout, like and then the best thing which 5G can offer in education is scalability. Like, for example, I can talk about a few examples. So we did a project where we created kind of like a virtual environment of Hudson River, which is the river between New York, United States, and New Jersey, the two states. There's a big river, and that gets polluted over time. And we were able to create a virtual environment just to create awareness. And then kids or the students, they were in that environment, and with the sound of the water, and then the marine life moving around them. So that kind of environment or that kind of experience was not possible before. And then we were able to do that with students joining in from different parts of United States. So a small example like that, like when we experienced it, it was actually amazing. Like, one thing, you talk about how much we can do with 5G, and then when you actually see it, that experience is just simply phenomenal. And then we talking about virtual classrooms, there was another project which we did, was kind of like a escape room, where students joined in as a group, and they were required to solve puzzles in terms of like math solutions or different kinds of regular learning experience that they would go through books or through different mediums. But then now they are in the virtual environment, and they're actually doing things to actually and then learning in the process. So all of that we completely moved all the applications to the Mac, and then all the VRs or all the VR goggles were connected, and all the models would. So anytime a student or anytime an object or a scenario was required, it would just stream down to each goggle, and then because of such low latency, they couldn't tell if the application is in-house or it's actually being streamed. So actually, the experience was as if they are in a real life scenario. So that's just a small example. And then in terms of higher education, like Harvard Medical School has a lab which is shut down because of the whole COVID situation. So something like that can be converted into a VR environment, where students can log in from different locations, and they can actually look at different equipments. They can get trainings on different medical equipments, and at the same time, the whole classroom experience can be conducted. And then it's not necessary if everybody's in the same connected to through a same cell site, or they have to be very close by, because the average latency required for such learning experiences are not so not for all cases. The latency is the required latency has to be very low. So if people are even in states like California, and the distance between, or the latency between California to New York is like 150 milliseconds, whereas the application requires 300 to 500 milliseconds of latency, then something like that can be conducted between a number of students, and the learning experience can be conducted through that. And then there are a lot of applications, professional applications like trainings or medical trainings or firefighters or for example, if there's a technician or a plumber that requires a certain kind of training for a certain kind of equipment, all of that can be converted into a virtual environment, and then that kind of training can be leveraged by a number of students at the same time. So these kinds of things which are happening today, and then this is all I'm gonna say is my personal experience is that this is just the beginning. I still think 5G is still a baby, and then we have a long way to go, and we're gonna see some very exciting things in future. All right, that's it. For any questions, please feel free to reach out to me anytime. Thank you.
Thank you, Shane. Thank you. Would you mind to off the screen?
Mm-hmm.
So, all right, so the next speaker, let me introduce Professor Dr. David Soldani from Sydney, Australia, to discuss on the global 5G evolution, more focus on the release 15, 16, and 17. Professor?
Hello, can you hear me?
Yes.
Yes. What about the slides? Are those visible? Can you see the slides?
Yes, it's visible.
Yep.
Yes.
So thank you so much for having me today, and I'm taking this opportunity to present what the 5G is all about. So I will review the deployment and especially say something about the features and the enhancement of the technology. My experience is of about 25 years in the information communication technology field. And yeah, I worked on, with and for many companies, but I've been especially, say, serving the Nokia for many years, and Huawei as well, with a special role in running research and development organization. And 5G is the topic where I have dedicated the most, with I would say most of the contributions. Let me see what I can move. Yeah. So these slides represents the status of 5G globally, and let me take the pointer. Yes. And in particular, reports the numbers of commercial networks and where the 5G has been deployed. It's of course intended, we are talking about the release 15, so a network that has been finalized already in 2018 and 2019, and this year we are experiencing a massive deployment and network rollout. You may see here the numbers. I've taken those very fresh from the GSA, and we do have already 81 commercial 5G networks over 40 plus countries. Australia already launched commercial services with Optus and Telstra. But more importantly, what we are observing on this slide is the massive deployment of the 5G system in China. And the numbers are also fresh. What we have here is that China has already rolled out 250K base stations, accommodating more than 60 million units. And they have already enabled more than 400 5G applications, scaling up to 600 by the end of this year with the launch of 5G connected to the industrial internet. The prediction is by the end of this year, China will have more than 600,000 base stations and accommodating more than 180 million terminals. To give you an idea is that for Australia, for example, will be more than sufficient to deploy 10,000 base stations with a population accumulated mostly around 5 cities, around 25 million people. So you may see the economy of scale of China, how large it is compared to the rest of the world. Now, the question is, yes, but at what frequencies these services are deployed? So where is the spectrum currently utilized, which also allow us to achieve the economy of scale so people can roam all across the world? And look at this slide. We do have the two main bands are currently in use. So we do have for example, the deployment US, but also in Korea and Japan and other countries in the millimeter wave. But that would be this bar here, where you may see here that around 123 operators, they've already launched services, especially around fixed wireless access, less mobility with millimeter wave. You can't move much. But the massive deployment is currently ongoing and will dominate in the C-band, which is around the 3 gigahertz, especially, I would say, in the overlapping of these two bands, where we have already 173 operators investing to launch the services. The question is, yes, if the network is ready, is the ecosystem ready? And the answer is absolutely yes. So it's the first time in history that we can witness this interesting situation. Usually you'd have the network is ready, and then we need to wait for the terminals availability to start enjoying the services. But that's not the case with the 5G. As you can see, taken also from GSA, the report come a couple of days ago. We have more than 300 plus devices available with a variety of type of terminals. Most of the terminals available are smartphones, but we have plenty of CPEs, which is around 30%, and other type of forms, such as connectivity to laptops. We do have dongles, and then gateways, drones, also robots ready for connectivity to 5G, tablets, switches, and so forth. So the ecosystem is there, and it is impressive how many vendors of a variety of devices are already making their products available in the market. Now, I would like to rapidly go through about the 5G in particular. Today, I think the topic was to look at its evolution. So we will not touch upon enhancing the mobile broadband experience, and neither talking about fixed wireless access, which are the use cases we are having right now in many places in the world. So the focus here is to looking at what's coming next. So what's going to be finalized this year and then next year. And I'm talking about the phase 2 of 5G, so release 16. And in particular, I want to say something about release 17, which will be then a topic to be finalized next year, but then with the launch beyond the 20 to 22. Let's start with the release 16. So the phase 2 of the 5G, which is finalized this year. And we will be having also commercial availability later this year, beginning of next year. For example, Singapore is expecting a lot of launching these kind of services. And what are we talking about? So the release 16, it is the fundamental enabler of the industrial IoT. So it is the foundation of the industrial IoT. And here I have marked in yellow what are the supported functionalities. So it is the first 5G version of the system that supports cellular vehicular to X communications. You know very well that the LTE is pretty much limited to broadcasting the signal. Now, with the introduction of new radio, we have the possibility of making communications car to car, so vehicle to vehicle, vehicle to the roadside unit, as well as vehicle to the pedestrian. At the same time, it further enhances the communication for the industrial IoT, improving the reliability up to the 6 nines. And that is through the enhancement of the features for ultra reliable latency communications. It also supports transmission using unlicensed spectrum, so that's very, very, very important, and enhances security as well. So practically, the release 16 will allow us to create private networks, use licensed, shared, and unlicensed spectrum. It has been designed and conceived for supporting ultra reliable latency communication, so connecting the big things. And it is also supporting time-sensitive networking, in addition to enhancing and supporting the positioning. And also for release 16, 25 study items have been finalized, paving the way towards release 17. And in particular, I think is of relevance, the study item on non-terrestrial networks, which means to use the satellites not for backhauling, but for access, so for complementing the access and providing much larger connectivity as services. Now, looking at the release 17 that will follow, we do have further enhancements on the industrial IoT, but I think what is especially of interest here is that the new radio, the radio interface will be enhanced and redesigned to support frequency above 52.6 gigahertz. Currently, the thinking is to extend it up to 71 gigahertz. And at the same time, we do have a feature for extended reality, further enhancing the positioning so that we have an accuracy of centimeter level. And more importantly, what we are having here is the introduction of the NR Lite, which is a new radio interface protocol that will allow us to further expand the communication for industrial IoT. But I think it is especially of interest because of the consumer IoT. We are talking about wearable devices. So here you do have below the slide the time frame and what this NR, so new radio light, does. It is the one I have here traced using a dashed line. So it's basically good at nothing, but it resolves all the problems. So it is a technology which is expected to support pretty much all the use cases I've represented here in the direction of industrial IoT, further enhancements, and consumer IoT. Beyond this, the release 17 will further enhance the cellular vehicle to X, as presented on this slide. As I've explained earlier, that the LTE was pretty much limited to broadcasting of basic safety messages among devices. And there is a release 16 that introduces the new radio as a side link, so the link between the devices that enables the communication between vehicles to the pedestrian, and then the vehicle to the roadside unit. And then the release 17 will further enhance the side link and the proximity services to support the critical communications and public safety type of application. So that's basically what I wanted to share with you today, just to give an overview of the characteristic of the system. And if you want to know about cybersecurity, I think you may make use of this link. I was recently explaining why the 5G system is more secure, and also its deployment much more reliable in terms of network resilience in that earliest generation. That's pretty much what I wanted to share with you today. Thank you.
Thank you, Professor Dr. David. Excellent. That was an excellent presentation. All right, so let's have a quick 5 minutes Q&A session. If anyone have questions on the 4 topics discussed earlier, you may post your questions now if anyone are interested.
I have one question, at least now, for Mohamed. How do you do the congestion control when you have links doing 400 gigabits per second? That's going to be funny.
I didn't hear the question actually.
Yeah. Sorry, yes. I have the thing. Yeah, so how do you do congestion control when you have links doing 400 gigabits per second? So it's the challenge is that if one of the links fails, you have to have a lot of capacity in other links to distribute the load. So you have to put a lot of capacity in the system, and the system has to be really fast to take decisions on, okay, this link is down, I need to put it into the other link. And 1 second of traffic, it's a lot of packets when you're doing 400.
Exactly. Yeah, very good question. Yeah, so there is a lot of enhancement. There are some enhancement to congestion avoidance. Usually we use quality of service, and we have now hierarchical quality of service to support, even give different software queues to different services. So maybe you have like end-to-end controlling the quality of services for mobile broadband or for IoT. And when it comes to this such large bandwidth, that's why we need to make sure we have feedback from the network. So there was a lot of protocol developed to monitor the performance of the devices and the performance of the links. And this performance, you can tune it maybe for each 1 second, each 3 seconds, 30 seconds, and share it with the controller. And the controller will be able to tell if this link is the reliability of the link and the load of the link. And based on that, can switch the traffic to another link.
Yeah. Interesting.
Yeah.
Yeah.
I have another question here. I mean, maybe anyone can able to explain, or perhaps a professor will be able to explain on the unlicensed spectrum for 5G. What kind of a specific subband that we are looking at for in this aspect?
Yes, for the release 16, we are talking about the 5 and 6 gigahertz bands, and then later it will be enhanced because especially I think in the US you have a large amount of spectrum available, a license at much higher frequency.
Right.
Yeah.
Okay.
But I think the bandwidth, it should be 150 megahertz using the CBRS in US. Am I right?
I have a question to Said. We've seen now, so I don't know if Soti has been satisfied with the answers here before I jump to my question to Said.
It's fine for me. It's fine for me. So it's just a comment on top of this, yeah.
All right, thank you. So Said, so we have seen this pandemic situation across the globe. And in terms of education, what are the promising applications to deliver cross-reality via 5G? And the second question is, what are the main KPIs to guarantee the quality of experience for cross-reality users?
So the promising applications are currently I'm involved with it's kind of like a national initiative where all the nursing schools in the United States are actually converting their trainings into either a complete virtual environments, or at least some kind of experience where students can learn remotely and be in a classroom like environment. So that's basically the goal, and a lot of projects are going on because unfortunately these are hard times for everybody, but it's kind of like how we can prove what 5G can do. So it's kind of that scenario. So a lot of schools and educational institutions, they are actually experimenting. So we know we can do like a Zoom classrooms and Google Hangouts kind of classrooms, or those kinds of things. But then there are limitations where it's very difficult to keep the focus of the students. So that's why it's much more needed than any other scenario to actually move the whole environment into a virtual environment. So that I think that's what the focus is right now. And what was your other question?
The other question was, what are the main KPIs in terms to guarantee the best quality of experience for the end users being served with cross-reality applications?
One thing which we have noticed is that the biggest KPI for a virtual environment is I think lower latency, because like I mentioned before, if you go above if you keep your latency under 5 to 20, then it's and then it also depends on how compute intensive your application is, like what kind of environment you have created. But if you go above let's say 30 to 50 milliseconds for a very where a lot of things are going on, an environment where a lot of things are going on. So in that case, the experience become worse, because the user experience is very important when it comes to VR. So I think the biggest KPI is lower latency.
Thanks.
No problem.
I wanted to ask everyone about the opinion of Microsoft acquiring a firm, a Metaswitch, and the welcome of IT players on the telecom arena. Now we were talking about the 5G revolution, okay? And previously it was only the big ones on the market ruling the specification and driving the innovation. Huh? It seems now that we are offering some part of the cake to the IT players back. No, what's your opinion? What do you think about it? That's a good one. Silence. So
a difficult question.
Yeah.
I was discussing.
Well, I've seen now Oracle, for example, that they sort of abandoned the SDM, and now they're back again into the game with the unified 5G core, and they want to compete also with their own cloud So not sure whether that's going to be really for tier 1, tier 2 operators, or that's going to be something for enterprises. There's going to be lots of room for everyone on the 5G. But it's something new. It's something that it didn't happen 10 years ago, and not even with 4G. No? So I'm not sure. It's an interesting thing.
Yes, I can comment. Basically, without disclosing anything around companies. Yeah, but if you see the fundamental difference here, we are having between the 5G, even looking at the radio interface with respect to the earlier generation network, is that now we have in place the speed, latency, and reliability. That what happens is that we tend to shift most of the application to the cloud, and therefore even close to the edge, so close to the base station. That allows you to create an offering end-to-end, which is very much oriented to cloud applications. So you do have coming together the connectivity and especially the offering on top.
Yes.
That enables many players, an ecosystem of players that they could offer not only service application, but we are talking about the application enablement platform. Then the core network is also service-based architecture. So
yes,
it is a composition of virtual function that in theory could run on top of any hardware. And then, so that I think opens the floor to many players, including also what happen at the edge and the devices themselves, which is a great thing overall.
Yeah, but also I feel that, for example, 5G, now we talk about IoT, we talk about massive devices, we talk about ultra reliable, but then when do we talk about voice and SMS for a regular consumer? It's simply that we simply have forgotten the regular telecom services, and we jumped into all this AI on the edge, which is interesting, don't get me wrong. But at a point in time, we need to replace the old network. We need to be able to offer the same service that we were doing before, okay? And what I said in my presentation is it's getting more complex every day because there's more countries with different technologies, with different radio systems, with different dial control protocols. This is getting a mess. So at a point in time, we need to stop thinking about the next thing and sort it out the past.
Yeah, I mean, it's going to happen step by step. So step by step, the technology will retire. And then I think a possible migration path is that you need to think of what services you want to deliver, and then modernize your core network. That has to be a multi-mode system.
Yes.
So you are slowly migrating and then retiring the other part of the access, like the voice over IP, as you presented, we will have initially through the LTE as a fallback from the new radio, and then also the new radio will take it over using IMS system. And the core network has to be capable, service-oriented, cloud-friendly.
Yes.
So that it's just a matter of upgrading software rather than replacing all the boxes.
Yeah, no, of course.
Slowly by refarming the spectrum and incentivize your end user to upgrade their terminals.
Well, it might be not even your users. It might be the cows that they are on the field, and you need to get the device from them to do a new device. Yeah. Yeah.
If I may add, I believe, as Dr. David said, 4G was more about connectivity and speed. 5G is more about user experience and services. And I see the challenge for the operator. Are they going to adapt to get monetize their expense, their spend and expenditure of building this 5G, expensive 5G? Are they going to provide some services over the top services, or they will leave it to software player, as you mentioned, Microsoft and Google, Apple, to take the benefit of the 5G? I believe it's a bit challenging for the operator to try to monetize and get part of the piece of the application and services over 5G.
Is that a question to me or to all people?
The other point I wanted to
That's a comment, yeah.
highlight is the network slicing. Are the cloud companies or the software companies able to do a full function of network slicing? That's another question, right? So because the telecom is the one who actually initiated with the 5G network slicing feature, special feature that that can able to tailor the needs of the end market. It's not just limiting to B2B or B2C, but B2B2B, and so it's an extra layer where the customers can able to specify the right requirement, whether they need the right bandwidth throughput or based on the use case that they wanted to the specific requirements, right? So this is an added advantage from a telecom vendor perspective. So,
but there's going to be limited business cases. For example, a factory, you can do slicing or IoT. But when you talk a bit about consumers, at least for the next 4 or 5 years, you still need the old HLR diameter traffic to be able to do roaming. And so the slicing is going to be only for certain really specific, like the other was the Bayern stadium put in for antennas for doing VR. That's perfect to put on a slice for this. Okay, that's no phone calls. It's simply to do VR. Okay, but is it going to be more for the edge IoT, something like that, for the real operators? I don't see operators doing a full-fledged of their network for a specific case.
Let me give you one point. So it's mostly for the big players like IT players. So why they thinking on it? This offering is to use their tools in the cloud platform or cloud network. So they see that is an opportunity to sell their platforms to the operators. So that's what they are joining with the vendors to go with the full offer, as David said. So it's a kind of a new space, but the one interesting thing in the telecom area we see is that big players going to invest on the telecom operators. For example, Facebook invested in India, one player. So it's the same news we are getting that Amazon also want to invest in another operator. So this game is changing. So where that traditional vendors going to be there is the questions for us in the 5G model.
If I can comment, if you look at the 80 plus network that have been launched already with and the services, what we have found, and I've been also in some of the conference with carriers coming from South Korea, is that the enhancing the mobile broadband experience monetizes. I mean, as long as you can deliver bits at lower cost for the end user, and you do have a corresponding applications that demand for such a speed and low latency, like for example in Korea, if you look at the VR or even AR offering, it is really used, and the revenues of carriers increase, and the offering of those operator goes, as I said earlier, well beyond the connectivity, because we are talking about Cloud X type of services like cloud gaming, like cloud PC or other type of applications where it is possible for the operator to leverage application on their platform, or provide and host other application for over the top to an end user, which can enjoy those applications which are much less expensive device, because all the rendering is done in the cloud, and then you just need to have a simple uplink and downlink command, because your device is pretty much like a streaming type of service. And then I think that the future goes into monetizing the latency. That's more difficult. So the hope here is that the ultimate offering maybe is slicing. That's an option with the possibility of having authentication of the slice itself, so that reduce the costs for the management of the slice itself will be setting a positive business case for the vertical sectors instead of, for example, building their own network.
So just a quick question. I'm not really an expert in these things, but I wonder, currently the business case for 5G depends on there being new services that we're talking about here, like VR and AR, or are there advantages naturally of having 5G for the regular customer? I mean, for the customer who just likes to stream basic things, is there an advantage for them switching to 5G? And for a business that's offering this service, is it in terms of cost, can they justify currently, or there is a need for the newer services that have greater bandwidth for this business model to work?
I would say that if we jump into the new radio, the density and I think that's a good efficiency just to operators to jump into 5G without having to talk about services. But it's true that they are looking for ways to monetize the investment, of course. Fixed wireless access, I think it's going to be the key for most of them.
From my point of view is that out of the three categories, I think the enhanced mobile broadband, that is the part where it offers the UHD 4K and 8K, the AR, VR, with the 360 degrees immersive experience, right, with XR. And that's where I think, in fact, Verizon is focused very much into deploying in more than 100 stadiums in US. So I believe the enhanced mobile broadband, it's a valid business case to give the rich content of experience, not only limited to the viewers inside the stadium, but also remotely for those who are watching from home. So that would be a very much a unique case. On the other part will be the ultra reliable low latency communications, the URLLC, because quite a number of manufacturing production plants, automobile industry are starting to implement end-to-end 5G user experience with like what a professor was explaining on the precise positioning, right? So very much involved into very low latency, and that actually increased the speed and the productivity and efficiency in the production side. So I think these are the two key areas.
Yeah, I mean, frankly speaking, if you look at the applications, we need like let us connect a drone, for example, right? If you want to use a drone for whatever reason, like in Australia, yeah, you could send out a drone for see whether there is something that may initiate a bushfire or a shark, or you may want to detect somebody whether he has a very high temperature. There were those manifestations recently during the weekend here in Sydney. We had about 10,000 people. So you may want to identify people whether they have a high temperature. Then means if you look at the performance requirements, you will need especially launching a drone in the uplink. So that means for transporting the video that is captured using your drone at a certain height, and then you want to report it. You know, the higher the drone, the more has to be the higher has to be the resolution for identifying a face or a shark instead of a stone. Like, and when you look at the numbers, you may see that you would need at least 50 megabit per second in the uplink, and a certain latency if you want to have a closed loop between your device and the command and control, and that an LTE and a 4G system would not support it. Yeah, that just gives you a flavor of but then when we talk about augmenting reality or virtual reality, mixing reality. They're all speeds above 50 megabit per second. If you want to have a certain resolution, at least 4K, for not saying 8K, is to be even higher. Yeah, so I think this is a fundamental enabling technology that you may have with a new radio in place, so with the 5G system.
Okay, guys, thank you. Let's move on to the next session. So the next is the rapid fire panel session. UC Berkeley students use 5G drones to prevent wildfires. There is a link between wildfires and power lines that have emerged in the past several years. In 2017, power lines owned by Pacific Gas and Electric were blamed for a dozen Northern California wildfires and 18 related deaths. So a report shows that these fires occurred because of poor vegetation management, resulting trees and branches coming into contact with power lines. So a group of 6 UC Berkeley students has developed a solution called Drone 200 that will combat poor vegetation management and vastly reduce infrastructure related fires by using 5G enabled drones. So let me introduce Drone 200 team from University of California, Berkeley, USA. I pass this baton to you, Erica.
Thank you.
Hello, everyone. Thank you so much for the introduction. We are the Drone 200 team. So I would like to start by introducing a friend of mine, Dominic. In this photo, he's a high school senior. If you look closely, you will notice charred branches on the tree and remnants of a structure in the background. This picture was taken in late 2018, just days after the campfire in Paradise, California. For those of you who are unfamiliar, the campfire was the deadliest and most destructive wildfire in California history. This fire led to the death of 85 civilians and covered an area of almost 240 square miles, with most of the damage occurring in the first 4 hours. According to the CAL FIRE, the campfire was caused by electrical transmission line owned by PG&E. It is very likely that vegetation contact with power line led to this disaster. Our solution to prevent disaster like this combines the benefit of a 5G environment with the flexibility and remote operability of a drone. Our goal will be to use drones to remotely conduct periodic electrical infrastructure inspections to find areas where vegetation may contact a power line. These drones will be positioned throughout the power line infrastructure network and will be remotely commanded to fly an automated pre-programmed inspection flight path. Our approach to the final minimal viable product incorporates each of these 5 steps, which are analytics for high fire risk location, identification of infrastructure-related wildfires, use 2D satellite imagery to identify vegetation encroachment, use Wi-Fi control drone to collect 3D imagery, and develop computer vision algorithm for fire identification and vegetation encroachment detection. If executed correctly, we believe our approach will prevent Dominic from ever again having to sift through what remains of his home as the picture shown here.
As the first step, we used around 2 million wildfire records that occurred in the United States from 1992 to 2015. Then we filtered out more than 1,000 wildfires that are caused by power lines, as we can see in the picture. Next, after we grabbed the distribution, we prioritized sites by 2 factors. First, the area with the highest fire risk. Second, the mountain area that needs the remote control. Then we found out 2 clusters. One is the Yosemite, and the other is the Sequoia National Forest. We decided to focus on the Yosemite area, as it is closer to us. As we zoom in, we can get the location information and spot the fire sites in 2D aerial imagery. Then we found out that vegetation management is necessary. However, the potential problem is we don't have a 3D imagery to measure the exact distance between the power line and the plants, such as either overlapping, touching, underneathing, or etc. Next. Transmission lines are federally regulated and maintained. It has clearly defined right-of-way easement standards. The easement is 75 to 150 feet wide. We developed a computer vision algorithm to measure the distance between the center line and plants. If the distance is less than 50 feet each side in real world, it will automatically send an alert. Therefore, our solution is to send drones for 3D real-time video streaming, as 5G has low latency. Next. This is our demo for detecting vegetation encroachment. Due to the pandemic, we simulate an environment on the balcony. Our drone streamed video, which allows our computer vision algorithm to recognize the power line and measure the distance between itself and leaves. Next. This is our demo interface for controlling drones. The interface allows us to see the battery condition of each drone, and we can pick the fittest one to deploy for an automated investigation. We will also be able to see the recorded videos and alert history for each drone. Next one, this one is a demo of showing us a Wi-Fi connected tele drone is performing a short investigation task. This simulation is done in the kitchen with stove fire. The drone is programmed to take an automated triangular path and streaming its video at real time to the backend. In real application, we will scale up the flight path of the drone and make it fly along the power lines. We will also use 5G to make sure our streaming is real-time and reliable. Then we're going to show how fire detection works in the backend. Our AI algorithm is running over the streaming videos and classify if each frame is safe. Like here, we can detect a fire activity. Then the drone will send an alert message to the human end.
Yeah, so as we examine the vegetation management market landscape, we've placed drone inspection companies in the upper left and satellite imagery analytics companies in the lower right. And of course, any of these companies merging would surely provide competition for our product. However, our solution is already fully integrated and we will benefit from, in this case, a first mover advantage, since we're developing our product from the ground up to leverage the capabilities afforded by 5G. Next slide, please. And in terms of market research, we found that here, at least in California, companies spend about $250 million a year on vegetation management. And assuming that we can provide vegetation maintenance and fire detection as our main product offering, our expected revenue per mile is about $940. 5G is key to the market, assuming that we are assuming here that one 5G enabled drone can monitor about 5 miles of power lines. Our core offering, so essentially, is a fleet of 5G enabled drones deployed over a personalized coverage area according to each region and each customer's needs. On the analytics side, we can provide complementary fire detection and vegetation management services, as well as maintenance. Overall, we like to think of our business model as a drone as a service model. And our stakeholders include satellites firms, whom we can potentially partner with for amplified growth, vegetation maintenance experts, regulators such as the CPUC, and potential partnerships with 5G telecom providers across the region. For our release, we aim to launch a pilot within PG&E's R&D division later this year. Then we would incorporate maintenance in order to provide our first utility partner with a full service offering, assuming that 5G is available soon. And after that, we look to expand throughout California and then to the rest of the US by late 2021. So with the emergence of 5G, of course, our project is just one of many applications that could combine 5G with drones. You can see here on the left side that the computer vision algorithm is detecting wildfires and floods here. And the idea is that we can fly these drones alongside, maybe high risk areas for flooding and fires and streams to kind of detect potential risk there. And in addition, we can use pole detection on the right to help our algorithm. Right now, it's primarily reserved for vegetation detection, but in the future, we can do potentially infrastructure inspection and special delivery as well, including medical supplies. Next slide, please. So another potential application that's very relevant in today's world is social distancing. You can see from our computer vision algorithm here again that using a CCTV network, a field officer can track the compliance of social distancing rules among citizens. So if the camera detects a distance of less than 6 feet, among people, the algorithm will flag it with red lines, indicating that people are potentially at high risk here. And it will also be able to show, for example, how many people are violating the rule. So that's all we have from Drone 200, and thank you for your time.
Thank you, Drone 200 team. That was an excellent presentation. So let me take the honor here to introduce the advisory panel led by the 5G IPTV drone and satellite experts. We have Dr. Siva Sodhi from Reims, France, Paulo Rufino from Sao Paulo, Brazil, Christopher Luanga from Singapore. So let's have this 10-minute session. If you have any questions to be posed to Drone 200 team, please.
I'll start. Very nice presentation, guys. I think you've done a lot of the things that would be expected in a presentation of this sort. I'm actually doing satellites, so I'm interested in understanding in what way, because the satellite has this advantage of looking over an area. We just need one satellite, we can cover a lot of area, and fire detection is definitely one of the things that satellites are able to do. So I'm wondering whether is your solution more focused on fire prevention? That's what you want to be the niche area you want to focus on, to identify places where the poles are too close to trees or something like that. Is that correct?
Yes.
I see. Okay. That makes sense. Then that makes sense. I think that's a different application.
I would like to leave a comment. I think the solutions that you're providing, especially for forest fires, is so relevant for today. Looking at the Amazon fires and the fires in Thailand and Australia. So I think you have a very good solution, but once it detects what happens, like even in your social distancing solution for the, it detects the distance between the people, what happens next? Do you provide a next action plan or you just detect and that's it?
So for right now, we only have the detection and then it will send a warning to humans, so human will be aware and do the next step. But in our planning, we plan to have also allow the drone to do maintenance. So once we detect there's something wrong with the power line or there's like a plant that's too close to the power line, we would like to have drone to do some of the easy maintenance, such as like spraying on top of the power line and then maybe replacing broken parts. And that will be a next step, but currently we don't have a demo for it now.
Well, I just want to say thanks for all of you. It's a great opportunity to see this work. And as I'm based here in Brazil, very interesting moment we are living. And I've seen one application and just bounce back to what Christopher have asked before related what else 5G can provide. We can see here clearly so many applications. And past week, Brazil is being hit hard by COVID-19, especially because the way the infrastructure of the federal government is not providing clear information and details. But despite of politics, the interesting things, I saw one application that is going hand in hand with what you have presented. So in north of Brazil, in the state of Pernambuco, Recife, last week they deployed, I think it was the last couple weeks ago, the police department and some research department there, they deployed drones to understand the social distancing in that area. And also answering what Hanislam has asked you, some of those drones were sending warning messages for the citizen on the streets. because they were overseeing shops that are not essentials and should be closed and were not, before the police could go there and warning or send a fees, penalties. And also they were sending a voice message across the town. I think that's an interesting thing. But now my question to you, how is the next evolution of this? Because as far as understood, these drones are manned by you, so manually manned, so you control them. Is there any evolution to have unmanned drones just going autonomously and search for the area, look for spots there are potential risks?
So currently our drone is not manned, it's not controlled by human, it's controlled by the computer. So in our demo, everything is automated. So we program the drone to take flight at a certain time, and then it will go through a particular planned path to do inspections. So I think it's, if we wanted to go to random places and go inspection, it will be easy too. Because right now we're just giving it a path. But if we wanted to go randomly, we can maybe add some random variable to the program, and it will take an unmanned path.
Thank you.
Okay, so really interesting work. So keep it up, the drone, what you all are doing. So what I have seen that regarding the 5G, so which slice you plan to use it if you want to use it with the 5G, because it's a EMBB or it's a ultra low reliability. So it's, or you don't have any idea to use 5G. So because I see there are some Wi-Fi connections you are using to, please go ahead.
This is a really great question. As currently as our environment, we don't have an environment that fully, fully equipped with a 5G environment. And also it's like pandemic, we cannot, even though there is some like particular area that have the 5G there, it's so hard for us to being there. That's why we are using the Wi-Fi connected drone as a first step. Since the Wi-Fi connected one can work, then we believe in future when 5G is enabled in most areas, then we can directly modify some, directly use the drones that have using the 5G chips in there and have different things without like modifying a lot to make it work.
Yep. And I have one additional point for you also. I guess some point that edge computing can help you. So if you are using the mobile networks, so you can think on it. So how to use edge computing. So if you want to do some really corrective action. So if you don't want any corrective actions, it's okay. You can use whatever it's today you have with the 5G. But if you want to use some very quick reaction to some action drone can do, then maybe edge computing can help you in the 5G. Maybe some additional comment for you. Thanks. Keep it up. Good work.
Thank you for instruction. That's great.
Yeah, I think you've done a great job. And yeah, it would be applicable here in Australia as well. There are many cases. And I think also for the COVID-19 pandemic, you have shown also interesting application and also working. And you may think of expanding the possibility of capturing other type of signals. So that, for example, when you have detected the person, you could measure the temperature of the person. In that case, you could show that that probably is a person at high risk, and say, and then you would need to, I'm not sure how to inform the people, because you would need to provide them access to the information captured by the drone. But definitely, I think an integration with the authority that could, for example, augment what he or she could see using glasses. It would definitely help into analyzing the situation in a good sense, in a way that we can detect what happened and therefore increase the level of freedom of people. Yes, great job. Maybe one of the challenges you need to start thinking about is if you integrate the drone with a 5G model, you need to think of the requirements you need to support, especially in the uplink speed, latency, and then you would need coverage and what kind of spectrum band you would intend to use in different places. For example, the US, I think the deployment of 5G is especially in the millimeter wave. So in the one end, the millimeter wave will provide you a lot of band, but it would be easily out of coverage, or you would be a bit of a challenge into the mobility. Have you been thinking already about these things? Because I think that what you have done is really a great job.
Yeah, thank you so much for the comment. So we have been presenting this to some other conference too, and that's always been a problem. Like, what if there's no 5G coverage in the rural area? So yeah, that's something we have been concerning, but it's like we can't do much about it right now. So like as a beginning, maybe you can start to do some testings around area that has 5G, but in terms of like coverage in the rural area, we will have to maybe do, talk with the provider or the government.
Rural area will not be covered very soon, the 5G, because the coverage is depend on the frequency that we are going to use. So because operators have a different options to deploy, so maybe they will use LTE to remote areas and 5G to the like some urban areas. Maybe one of the use case like a NR radio, what is Dr. David says in the presentation. So it is in the future developments. That's also one of the options. So there are some tuning we have to do it in the radio part. That's sure.
And also depends on how real time the application is, how much information they need to process and see right away. Another challenge actually which we have seen and experienced is the FCC laws, especially in US. Did you guys looked into that? Like the drone has to be line of sight and those kinds of things.
Yes, we have a look into we aware of the law of FCC, and we are like asking our professor about like those terms, and like we plan to like come up with some idea, but now we don't have any idea for the law yet.
Okay, but overall, it's some amazing work that you guys have done. Yeah,
Thank
good
you.
luck.
In terms of coverage, the other option is, of course, satellites. People are thinking about building satellite constellations and bringing 5G signals directly to a terminal, like on your drone. Okay, so that is actually something some people are working on right now. At least one company in the US wants to do that. That is to say, no separate terminal, just the regular terminal we use. I mean, the regular antenna you use, so that your drone would not have to be bigger just because you want to receive a signal from a satellite, right? So in that case, I think it would cover you just about anywhere. At least most places you'd be covered, even in rural areas, if you can connect directly to a satellite. Currently, there isn't one deployed, but there is a couple of people talking about deploying networks of this sort in the satellite community.
Also,
Yes.
just to add up to our conversation, just share the link of this drone, and Dr. Soldani talked about measuring the temperature. This drone here in Brazil was doing exactly the same thing. He just was measuring the temperature of the people on the streets as well. And maybe other guidance on this topic for you would be, there are some applications for 5G on power grids. I know that there is a case study of Ericsson, and maybe a good opportunity for all of you to reach them out and maybe discuss this. Try to use this on the power grids that exist and you are trying to measure and build just a pilot as well.
Cool. Thank you so much for your advice and the link. We're going to look at.
So it is interesting.
Suggestion here. If Drone 200 team have worked together or have proposed to the mobile operators in US like Verizon, AT&T, or Sprint. If not so, then maybe you could try to communicate or try to see, just send an email to the contacts in those mobile operators, because usually they used to do a field trial test on the new applications for under the 5G flagship. So who knows? You never know. Maybe if you have a chance to do it a trial, that will be excellent for you guys.
Yeah, that would be really great. Like we were thinking about it too, like to connect to like GSMA. Like they just like connect us, like to provide the opportunity to share our idea through their network. And so we were thinking about like free deploying, like that's you mentioned.
Yeah, that's good. Keep writing them, not once or twice, a few times. I can assure you, definitely you will get a call from them.
Thank you. Yeah, we will do that.
Basically, I think the 5G would help you definitely, because if you look at the fundamental characteristics of the new radio has, it comes with this beamforming. So with the beamforming, you will easily then think of illuminating not only down, but it would allow you to connect nicely your drone when it flies. And I think the expected height is around 300 meters. Above, you need a different type of solution. Also, checking now as we speak, the internet. There is a report from OpenSignal on the recent speed provided in the US. And you have, of course, a company like Verizon reaching up to 400 plus megabit per second. I think it's due to the microwave, but I think you could be interested as well into data carriers, and all of them are providing new radio speed above 47 megabit per second. So I think it's I think that there are great opportunity to start thinking of using the new radio and enjoy new applications.
Cool, thank you.
Thank you so much for the suggestion.
Oh, I think you're muted.
All right. All right, so this session has now come to an end. I hope it was beneficial to everyone. I would like to express my sincere appreciation to all the speakers for your time and support. Thank you, Hani Islam. Thank you, Miguel Montfort. Thank you, Mohamed Radwan. Thank you, Shade. Thank you, Professor Dr. David Soldani. Thank you, Drone 200 team. Thank you, Erica. Thank you, Lumin Chen, Wanzir Yazar. Thank you, Chris Yuan Chen. Thank you, Dr. Siva Sodhi. Thank you, Paulo Rufino. Thank you, Christopher Luanga. Thank you, everyone. We never know where this journey will lead to. I'm wishing a great success to all of you in your future endeavors.
Thanks, and same to you
Thank
all.
you. Thank you so much.
Thank you.
Thanks for the invitation.
For opportunity, Ganesh, for all of you. Bye.
Yes.
Bye.
Safe.
Cheers. Bye.
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 Ciao, ciao.